Have you ever bitten into a lemon? That sour, zesty zing? That's an acid at work. Ever felt soap between your fingers? That smooth, slippery feeling? That's a base doing its thing. Science isn't just bubbling beakers. It's in your kitchen, your bathroom, and even your stomach. Understanding acids and bases explains cooking, cleaning, and health. Tart yogurt? Acid. Cookies rising and stain cleaning? Often a base at work. They're opposites, like hot versus cold, up versus down. By the end, you'll see how they meet in a reaction called neutralization and why it matters. Let's get started. Science is all around you. Let's learn its language. So, what is an acid? Let's keep it simple. An acid often tastes sour and reacts with other materials. Lemons and oranges get tang from citric acid. Vinegar's sour smell comes from acetic acid, and it cuts grease. Scientifically, acids release hydrogen ions, H+, when dissolved in water. Those H+ ions drive reactions. That's why acids can corrode metals or sting a cut. Food and drinks contain gentle acids too, like lactic and carbonic. Some acids are weak and edible. Others, like hydrochloric or sulfuric, are corrosive and dangerous. Strong acids require trained handling and proper safety gear. On the pH scale, lemon juice is weakly acidic. Battery acid is very strong. Key idea: acids taste sour and produce hydrogen ions in water. If acids are sour, bases are their bitter, slippery counterparts. A base often tastes bitter and feels soapy. A familiar base at home is baking soda. Soap is also basic. Its slipperiness helps wash away grease. Bases are chemical opposites of acids. Scientifically, bases produce hydroxide ions, O-, in water. Think of OH as negative partners ready to pair with H+. Bases range from weak, like baking soda, to very strong, like sodium hydroxide. Strong bases are caustic, handle only with gloves and eye protection. That slippery feel? A reaction with skin oils. Great for cleaning, hazardous if strong. Summary: bases taste bitter, feel slippery, and release hydroxide ions. Now that we've met acids and bases, let's see what happens when they meet. We have acids, rich in H+, and bases, rich in OH. What happens when they mix? They neutralize each other. Neutralization is when an acid and a base cancel out. It's like a chemical handshake. Reactive becomes stable. It's all about balance. Positive H+ is irresistibly attracted to negative OHE. They snap together. They form H2O, water. Core idea: acid plus base yields water. Other parts left over combine to form a salt. In chemistry, a salt is any ionic compound from an acid-base reaction. Complete reaction: acid plus base makes water and salt. This transformation powers our bodies, industries, and planet. Let's walk through it step by step. Imagine one beaker of acid and one beaker of base. We mix them to see how reactivity becomes neutral. Goggles on, let's begin. Step 1. Two separate solutions, each with distinct properties. Acid, hydrochloric acid, HCl, full of free H+ ions. Base, sodium hydroxide, NaOH, full of free OH ions. Each alone is hazardous. As soon as they meet, H+ from the acid finds OH from the base. Opposite charges attract. H+ and OH combine to form water. Water is neutral, neither acid nor base. Leftover ions, Na+ and Kl, remain. They link to form sodium chloride, NaCl. The final mixture is neutral salt water. In science, equations are recipes. Reactants go in, products come out. The general neutralization formula is simple. Acid plus base reacts to form salt plus water. Left side, acid and base. Arrow means reacts to form. Right side, salt and water. Example: hydrochloric acid and sodium hydroxide yield sodium chloride and water. Written: HCl plus NaOH yields NaCl plus H2O. Atoms just rearrange. Nothing is lost, nothing created. Neutralization isn't just lab stuff. It's everywhere. Your stomach uses strong HCl to digest. Too much acid? A weak base in antacids neutralizes it. Result? Relief. Acidic soils from rain or fertilizers are neutralized with basic limestone or wood ash, bringing soil pH back where plants thrive. Acid-base spills are neutralized, baking soda on acids, vinegar on bases, safer cleanup. Municipal plants adjust pH to prevent pipe corrosion and ensure safe drinking water. Skin and hair are slightly acidic. Acidic conditioners neutralize alkaline shampoos to restore shine. Bee venom is acidic. Baking soda paste can help. Wasp venom is basic. Dab with weak acid like vinegar. Serious reactions? Seek medical help. Scrubbers spray basic slurry to neutralize acidic gases before they form acid rain. Result: salt and water instead of environmental damage. In the kitchen, recipes pair baking soda with acids like buttermilk, vinegar, or lemon. Neutralization makes salt and water and releases carbon dioxide bubbles. Those bubbles get trapped, making bakes light and fluffy. Without it, baked goods would be flat and dense. Tip: ensure an acid is present when using baking soda for proper lift. Let's bring it home. Acids, often sour, they release hydrogen ions, H+. Bases, often bitter and slippery, they release hydroxide ions, OHE. Two sides of a chemical coin. Together they don't just mix, they transform. Neutralization, H++ OH, becomes water. In words, acid plus base gives salt and water. We saw it soothing stomachs, fixing soils, treating water, helping stings, cleaning air, and making fluffy bakes. A handy tip about antacids: use them wisely. Stomach acid kills harmful bacteria and aids digestion. Use antacids for occasional relief, not constantly. Frequent heartburn? Talk to a doctor. A little chemistry helps you use everyday products safely.